So our next section is the panel discussion. Geologic underground storage, geologic CO2 storage is a very active research and development topic over the past few decades. And over the past several years, we have seen so many innovations in this field that brings some new challenges, but also at the same time bring a lot of new opportunities. Today, we have invited experts from the industry and from academia to discuss the innovations, challenges, and opportunities of underground storage. Please join me and welcome Dr. Matt Herman from CSUB, Rob Trautz from Alpert, Mike Umbro from Premier Resource Management, and our moderator, Lisa Alpert from Aera Energy.
You have an option. You got a couple options.
The moderator, you get to do what you want.
I'm assuming I'm standing here. Thank you for having me as a moderator from Aera. I'm also adjunct professor at CSUB every now and then. It's very fun. We've heard from Dr. Petridge about some of the opportunities, a little bit about how Kern County offers opportunities for CCS. Today our panel is going to talk more specifically about what those opportunities are, how they see the future of carbon capture in Kern County, and get their ideas of where we're headed and what might be in our way. So thank you for being here. Today we're going to start with, where do you see yourselves in this path for energy in California, who you are, and what are the specific opportunities for CCS in Kern County? So let's start with Rob Trautz from Electric Power Research Institute.
Can you hear me? Oh, it is on.
There you go. You're good.
The light isn't working, so. Anyway, good morning, and thank you for the opportunity to be on the panel today. I'm Rob Trautz. I'm a hydrogeologist at EPRI, and I've been working in CO2 storage since 2004. So I'm very bullish on CO2 storage. I think, especially in this area of the United States as well as California, the opportunities are really bountiful, because we did a study back in 2018 where it was the first carbon-safe project that was in California, and we did an assessment on the southern San Joaquin, and there's a marvelous resource available for CO2 storage in this region. It's great. About 5 years ago, 6 years ago, CO2 sequestration, capture, and storage was kind of on, I'd say, on the decline, and we're seeing a new wave of investment coming from both the DOE as well as through the IRS 45Q tax credit that makes it economically more attractive, certainly. So I think I'm very bullish on it. I think there's a lot of opportunity here. You've got the resource, the geologic resource. You have the workforce that's here, because you have been doing oil production and natural gas production for 100 years in this area. So you have the workforce, you have the human capital that's there. So it really, this area is prime to take on the challenge of doing CO2 sequestration for California.
Thanks, Rob. Dr. Matt Herman from CSUB, Geological Sciences.
Hi, I'm an assistant professor here in geology, and I work on geophysics. And I think the need and the opportunity is now. That's what Dr. Petridge said better than I ever could. And we have the technology. We have the ability to be taking carbon dioxide out of the air. We have the ability to be putting it underground. So I live here in Kern County. I have a vested interest in making sure this is done safely and done well, but I also live here and I don't need my summers to be 5 degrees Fahrenheit warmer than they already are. So I see this as something that needs to be happening, and we have the ability to do it. So yeah, let's take that leap now.
Thank you, Matt. And Mike Umbro from Premier Resources Management.
Yeah, absolutely. Good morning, everybody. My name is Mike Umbro. Born and raised in San Diego. I still live there, and we're developing, as a company, a geological thermal energy storage project on the west side of Kern County. And I manage a nonprofit called Californians for Energy and Science. I think the biggest opportunity for carbon sequestration is a teaching moment, in that the industry that has been developed here for over 150 years, as we've talked about, can teach the people of California what exactly is an oil reservoir. Yes, it produces oil, but what can it do for our energy renaissance that we're embarking on in repurposing that reservoir to store carbon, to store thermal energy, to address the issues we're having with not only air quality, but affordability with our utility rates. And again, another teachable moment where we can teach Californians that, hey, you know those oil and gas reservoirs, we store all our natural gas we need in the wintertime in those reservoirs. So in essence, we're already storing gas in reservoirs. And I think it's something that we can use as an industry and people here to take students on field trips out to the field. And so I think it's a tremendous opportunity to educate just how vitally important reservoirs are and pore space is to not only this community, but the entire state.
Great, thank you, thanks. So those are some of the opportunities, but we also have quite a few challenges that we touched on, and Dr. Petridge touched on. Specifically, one was seismicity. So the potential for induced seismicity in the valley is an issue that's addressed by the scientific preparation for these projects. Can we talk specifically, Matt, what are your thoughts, considering you're a seismic earthquakes hazards specialist?
Yeah, well, we already have a lot of earthquakes in California. So we have built a lot of resistance to earthquakes here in California. I think we are largely prepared. But what people maybe don't realize about earthquakes is, they're all worried about the big one on the San Andreas. But frankly, a smaller earthquake closer to home is just as frightening to me as a large earthquake as far away as the San Andreas, which isn't all that far away. But the question is, are we going to induce seismicity if we store carbon dioxide in the ground? We know there are faults. We know they're sitting there sometimes, and there's gas, there's water in these units already. We have the ability to pump things into the ground at the same pressures that already exist, but the question is whether that's going to be sort of a stable process. And I don't know the answer to those questions, but we can figure out the answers to those questions. Part of it is making sure that we're observing the natural systems very well, where we're trying to do these things. Part of this is trying to understand how CO2 actually interacts with rocks, fault rocks, things like that, and changes the properties of the underground system. So I'm fairly optimistic that we can take steps to mitigate those potential hazards.
What kind of steps do we take?
I think it's mostly about monitoring. So we have to check for things like microseismicity before we induce an earthquake on a larger fault that would produce a larger magnitude event. I think it's also things like monitoring for deformation, monitoring for gas migration where it's not supposed to be. So there's sort of an integrated monitoring system. And I think that's already in place through various regulations. These things are not being done secretively. These are being done in a well-monitored way. But I think that's really going to be paramount to making sure that CO2 and other things we're pumping into the subsurface is done without triggering earthquakes and damaging people's houses.
Is there an acceptable level of microseismicity?
That's a great question. Places we've seen microseismicity before, it tends to not stay microseismicity. That's been my experience with induced seismicity in places like Oklahoma and places like Groningen in the Netherlands. The induced seismicity is small until there's a big event that is more damaging. And exactly what causes a bigger event to occur versus staying small, that's an area of research that we earthquake scientists would like to know naturally as well. So we don't have answers to those questions, but my opinion is that we would like to not see any increase in seismicity at all.
Okay. Rob or Mike, you have any comments about that?
Yeah, I think from a project perspective, there's things that you can do to help try to mitigate it before it actually happens. Mark Zoback published a paper several years back from Stanford University that looked at the brittle Earth. We know that the crust is potentially brittle, and there's a lot of faulting and large faults in the basement rocks. So one thing that we've pretty much noted that if you've got a confining unit that sits between your injection zone and the basement rock, that will help to dissipate the pressure before it gets into the basement. Now, as part of your due diligence when you go to site a project, you're also going to look at faulting. You're going to get your seismic data, you're going to do your 3D seismic potentially, and or look at legacy and identify those faults that are cutting through the geologic section. Now, not all faults go up to the surface. Some of them actually, they'll peter out before they get to the injection interval that you're actually going to do your project on. So identifying those and trying to stay away from those that actually intersect the target, basically your CO2 storage unit, is important because you can try to pick sites that avoid where those faults are, or they terminate deeper in the geologic system, so you're not going to propagate that pressure to that fault and reactivate it. So there's certain things we can do as project developers to go in and make smart decisions and try to avoid those situations like this.
Great, thank you. Mike, any comments?
I think they explained it great. From a project development standpoint, it's about selecting a site that's for us. We picked a site away from homes on the west side, and then from there, you look at what does your reservoir, what does your container, what are the characteristics of that container? Do you have a good container for sequestration? Do you have a good container for thermal energy storage? Whatever the process is that you're implementing. And again, that's where the education can come in, bringing students out, bringing the community out. If they want to go all the way out to the west side and see what operators are doing out there to really get an experience. I think a lot of people are visual learners, and it's another opportunity to educate. How do reservoirs work, and what do these projects look like at the surface?
Does that happen frequently with the regulators? Do they come visit these sites that you're familiar with? Do they see where they're talking about those projects?
I would love. No, actually, we've actually had our lab partners. We're partnered with NREL, Lawrence Berkeley, and Idaho National Lab. Some of our lab partners have visited. I think it is something that, as we look at projects and agencies in the state, CalGEM, CARB, whoever, should be visiting these sites and seeing what developers are doing, absolutely. And they do, but it's an opportunity to have more regular visits.
Great.
Faulting is one of those things that is a really big challenge, I think, for CCS. It really is. You think about a large fault where you'd have an earthquake on it, could be several kilometers long, correct? And several kilometers deep as well. And trying to characterize with an 8-inch diameter wellbore a fault is going to be a very difficult situation when it covers such a long distance. So it is a big challenge. And there are groups that are looking at flow-up faults, research groups. There's a group over in Australia that's doing CO2 injection into a fault plane, seeing how it will propagate up the fault. So there are groups and research going on in this area, so it's not devoid of information at this point.
And some of these faults can actually help with lateral
They can. They can be
containment.
bounding faults or they can be sealing faults, for sure.
It's just the question of how do you prove that they're going to contain it? So, great, thank you. So we're talking about Kern County because we have depleted reservoirs to put our pore space. With that comes the wells that we use to deplete them. So we know that we're surrounded by idle and poorly abandoned wells that have been here for maybe sometimes 100 years. So how do you address the issue? What's the concern with idle wells? Mike, why don't you start us off talking about that?
Again, it's a great opportunity to have new developers come in. We started in 2018, and our lease had 8 wells that had been idled there for 4 or 5 years. And so we returned 4 to production. We're abandoning wells from a prior operator, taking that responsibility and spending money to remediate the site. But from a project perspective, when you're permitting for underground injection control, you're looking at not only your lease boundaries, but an area of review that extends much beyond, miles beyond in these sequestration sites where your project is located, and literally tying in every well within that area of review. And some wells still have structural integrity. Some wells can be used as monitoring wells and repurposed. Some need to be abandoned, and some need to be addressed in the form of, well, we're not going to inject near that well. And so it's all about how the developer is managing the situation.
Rob, any thoughts on idle well management?
Yeah, so wells, inactive wells, plugged in abandoned wells, they're a blessing and a curse, right? They're a curse in that they could create a potential pathway for CO2 to potentially leave the target interval and get into the shallower groundwater system. But they're a blessing at the same time because as a geologist, if I don't have any well data, I don't have a project because I've got to define what that geology looks like, and I've got to use that geology to create a static geologic model, which I then do the reservoir simulations to prove in my permit that it's going to be a safe location to put the CO2 into. So they're a blessing and a curse, but at the same time, I think we can manage this problem too, because again, you can go in and map where the plugged and abandoned well bores, how deep they go, which intervals they penetrate, and again, in this region of the country, when you have over 40,000 feet of sediments on the west side of the valley, you have a lot of different stacked reservoirs in which to choose from. So there may be deeper reservoirs, or there may be reservoirs that haven't been penetrated by wells. And it's a matter of going through the inventory and looking for those wells and mapping them out, finding out whether cement was behind casing, where the cement was placed, and going through it methodically to show that you've got a well that may not require remediation. But if it does, then you're required by the EPA to do so. So you'll have to go in there, maybe drill it out, re-cement it, if you can get into it. That's always a challenge as well. But there are means of doing so. So I'm very optimistic that we can do this.
Is the funding for idle wells or abandoning wells or re-abandoning wells, is that part of these packages that we're soliciting?
Yes, so when you put in a permit, you're required to look at what they call the area of review. That's how far both the pressure front as well as the plume, the CO2, how far it will occupy in the subsurface. And if you have wells that are located within that area of review that could potentially be exposed to CO2 or push brine up into a shallower interval, then you're required to remediate those wells by EPA.
And Matt, what are your thoughts on that?
Yeah, I don't know much about the technical aspect of wells. It's not something I do. They usually don't let me out of my windowless office. But in my windowless office, I use a lot of remote sensing images, so seismic images, resistivity images, things like that. But those only tell us the physical properties of what's in the ground. As a geologist, as somebody who wants to maybe put CO2 in the ground, I want to know what those rocks are. And the wells are the only window we actually have to calibrate any of those geophysical images that we have. So I see these as an amazing opportunity. Having them there is much cheaper than drilling a new well, I think. So as I said, I don't know much about the technical aspects of wells, but I see these as critical to our ability to actually say what's beneath our feet and what can we do with it.
And that goes with part of the opportunities that the oil producers have in this area, because we understand the strat column. We can see where these wells are. It's really important to use that expertise in these projects. Talking about conduits, when we're talking about conduits, we're concerned about them because they can lead to migration of CO2 up into the shallower structures where you don't intend it to go. Also, they can lead to contamination possibly of groundwater. So let's talk a little bit about shallow groundwater and what this could mean. So Rob, why don't you start us off on the discussion of conduits?
Yeah, sure. So the underground injection control rules that EPA came out with for geologic storage back in 2010, the whole reason behind those rules is to protect what they call underground sources of drinking water, USDWs. That's defined by the EPA as anything that's 10,000 parts per million TDS, total dissolved solids, or less. So it's considered fresh water, although you and I would never drink anything that's got 10,000 ppm in it. You wouldn't probably feed it to, the rancher wouldn't feed it to their cattle or let them drink it because it's just too salty, frankly. We typically are drinking, groundwater that's on the order of, maybe 100 parts per million TDS, fresh water. So it is very saline, and it's typically very deep. In California, that's always been a bit of a challenge because many of the USDWs, at least in the oil and gas, have been quite shallow in terms of, because they use a slightly different TDS value, and it hasn't really incorporated that into the EPA. EPA is still 10,000 ppm, so you have to agree to that. So EPRI, we did a study with Lawrence Berkeley National Laboratory where we actually took groundwater, we pumped it out of a shallow, very isolated shallow reservoir, and we dissolved CO2 in the groundwater. And then we re-injected that dissolved CO2 and groundwater back into the system. And this was a research project because we wanted to look at what the impact of that dissolved CO2 was on the system. What happens when CO2 dissolves in groundwater, it lowers the pH, just like in our soda. The dentist tells you not to drink a lot of soda because it's got low pH and it will dissolve the enamel on your teeth. Well, the same thing happens when CO2 dissolves in groundwater. It changes the pH. And now there's other impacts as well. Because we have naturally occurring minerals and we also have clays which absorbed heavy metals onto their surfaces and or consist of heavy metals. So there is the potential for that lower pH groundwater to dissolve those minerals and or release those cations into solution. And when it's in solution, then it can be transported and potentially produced at a groundwater extraction well, municipal well, you name it, domestic well. And so there is a concern if CO2 were to get out of the reservoir. Now, in our particular case, we did see the impact of the metals increase when we did the research. We saw the metals go up as the CO2, dissolved CO2, passed the reservoir, and we were taking groundwater samples. But we never saw the actual concentration levels of the heavy metals exceed the EPA groundwater cleanup standard or the drinking water standards. Now, that's not to say this is going to be universal. So you have to do your due diligence as a project developer to make sure that A, you do your best to keep that CO2 in the reservoir, and B, if it does get out of the reservoir, then you have to have a response plan or mitigation plan in which to respond to that potential issue. This is nothing new for the EPA. They look at this, pretty much every day from underground storage tanks. It's, not much different, frankly, folks, and so they're used to this. It's just on a much larger scale, frankly, because these CO2 plumes are going to be very large in the subsurface.
Thank you, Rob. Mike, what are your thoughts on groundwater in the current
I think
county?
another fantastic teachable moment for folks when we've studied, and we've been studying for 6 years, our area on the west side. every geologic zone is contaminated with oil. We have high TDS brackish water in the reservoirs, and the process that operators and developers go through to prove what the characteristics are of the reservoir is very lengthy. And we know that the water boards is not a walk in the park, and they take their job seriously, as they should. But another important moment for laboratories, operators, developers, policymakers to recognize the speed at which we have to act. And when it's very clear that there is no USDW, that particular permit of many permits that are required to get a project off the ground needs to be processed, and it needs to be done efficiently. And that's another teachable moment that we can talk about the characteristics of, particularly where these sequestration sites are on the west side, and the value of locating these projects in an area that they can be minimally impactful to the environment and have no impact on USDWs.
Great. And Matt, how do they prepare for this?
Yeah, and as we do this, this is why these systems are monitored so extensively. Rob was just talking about how they're measuring the TDS and all these the pH of the water. This has got to be a comprehensive, integrative monitoring, and this these things are required. This is not something new that I'm suggesting here, but it's got to be part of it. And I even think industry or the people planning these things can take a step forward and say, hey, we're going to do extra to make sure that this is done in a safe, responsible way, and as Mike said, demonstrate this is not a danger, right? And if it becomes a danger, if it seems like it might be, we can pull back and figure out what's going on. But we have the knowledge, we have the observations to be able to say, no, right now this is being done in a way that's good for everybody.
Great. And being in California, a lot of this monitoring is already in place for many of the other projects that we've had to install it for. So we're ahead of the game on that one. So we're going to start talking about the future of CCS in Kern County. What do you think are the significant challenges, maybe not the ones that were brought up on a technical level, but what do you see as someone who's invested in Kern County and you've had years of experience in these projects? What are your thoughts on the biggest obstacles that might hurt us? Mike, why don't you start?
Clearly, the speed from project inception through permitting is a big hurdle. We've got to act quickly to really make this an affordable place to live, first and foremost, because if people can't afford to live here, they are not going to care about the environment, and climate is not going to register high on the polls, which we've seen in the data. So I think finding a place where policymakers and developers can get to some common ground to educate the public, bring people into these developments, show them what's happening, and get through the permit phase. I think that's the biggest challenge. And then with that is the cost of capital. Who's going to come in here, and how much of your project are they going to expect to take, because they know there's an added risk of permit delays. And it's a real problem, but there's a lot of money at the federal level and the state level for these projects, and if we don't move and show that and demonstrate that we can do so efficiently, we're going to miss out on that opportunity.
Great, thank you. Rob, what are your thoughts on our hurdles?
Yeah, so I don't feel there's really technical challenges at this point in time. I think we can do this, and I think we can do it safely. But there are two other challenges. One is just getting enough land holdings, and many of the companies here, you have large land holdings. In SB 902, they recently codified that the surface owner is assumed to be the pore space owner, which is good because now we've got some certainty on that. So if you own the mineral rights, you don't necessarily have the pore space rights. The surface owner may if those haven't been severed from the estate. So what this means to project developers is you're going to have very large area in the subsurface that you control the pore space. You may have to lease the pore space from the surface owner. And having unitization rules that would allow you to unitize that reservoir under one operator, just like we do in oil and gas, is very important because they are going to be very large. And fortunately, some of the groups here in the room, I know you've got very large land holdings, and therefore you can develop projects on your own property, but there may be other owners that need the same type of assistance through unitization. So that's one. And then, of course, the public challenge, engagement with the community, getting them involved at the early stages is very important because we will need a social license to operate, I can tell you, when it comes to CCS. So we're definitely going to have to get the public engaged in a meaningful way as well. It's not going to be we just stroll in there with the permit and we slap it down, hope for the 60-day period to end, and we don't get any comments. We know that's not going to happen. So early engagement and meaningful engagement, I would say, as well. And each community is different. So learn what the values are of that community and make sure you listen to what their values are and address those values.
We heard about that at yesterday's workshop, how
Absolutely.
important that was. It's a long timeline and it's a long road to hoe, but we can get there. Matt, what are your thoughts on?
Yeah, I agree with Mike and Rob that I think the major limiting factor is buy-in from communities and the people who this will affect or will be nearby or will otherwise sort of be involved with it. And I think, I'm an educator here, and I think education, Mike has brought this up a couple of times, is just really, really important. And I don't just mean students in my classes, that's great, that's part of it, but also making sure that we as scientists, everybody in this room, I think is on the same page here, making sure that we don't just stay in this room, that we go out into the community and we inform them what's going on. We tell them the risks and the dangers and the things we don't know, and there might be things we don't know, but say there are uncertainties here, but we do have a pretty good handle on a lot of it. And sort of being honest with them and telling them about the advantages that Dr. Petridge talked about and that we're talking about here, I think we can get people to buy in eventually. And I think once we have that sort of community support above some threshold, I'm not a social scientist, so I don't know what that number is, but I think we will get there. I'm fairly optimistic that not only do we have the technological capabilities, but we will have the social acceptance of this as well at some point. And so I think that's the major limiting factor right now to moving a lot of this forward, but I'm fairly optimistic that we will get buy-in. There will be continuing external pressures from climate change, and we as a community will demonstrate that this is safe enough to do and be a mitigator towards climate change.
Great. You're hopeful. Mike, you've been out there talking to the public, educating them. Are you hopeful? What are your thoughts?
Yeah, I mean, I got everything I own invested in this project, so I better be hopeful. I think, unfortunately, I've said for many years, it's price crisis will force action, and we're at $5.50 a gallon gasoline. It's April. Are we going to have 7 and 8? We've got the highest utility bills in the country. 20% of California households are in arrears. That's 1 in 5 households. So they need clean power, which the reservoir can provide. We need abatement, which the reservoir can provide. We need affordable local energy. The elephant in the room is we're all here, and this university is here because of a rich history in oil and gas, building this community, and the people need us. So I'm very optimistic that as the people seek for local options, they will know that we've been screaming from the mountaintops to give those solutions to the people, and we'll start connecting. I'm very hopeful.
Great. And Rob, you've been in this business for a while. What's your outlook? Are you hopeful?
Oh, I'm very hopeful. I think with the change in the IRS 45Q tax credit, that's going to help push the industry further to act. In California, you got the carrot and the stick. You've got the LCFS. essentially credit, and you've got the 45Q tax credit as well. But you also have the stick, and that's the compliance with the ratcheting down the CO2 emissions. So if you don't take the carrot, then you're going to get the stick, unfortunately. That's the way it is.
Great. Well, thank you for your comments. Thanks for being with us today. We touched on just a few things. You don't need to hear my questions, or we'd like to hear from you. Does anyone have any questions? We have a few minutes.
Thank you, Lisa. Excuse me, sir. We have one question from the online audience. The question is, the speaker mentioned storing carbon in oil reservoirs. Is a Class 6 permit required to store carbon in oil reservoirs? And how do these reservoirs differ from the saline aquifer? Do they require other permits? Thank you.
So if you're doing CO2 storage for sequestration, then you are required to get a Class 6 permit. It doesn't matter whether it's saline storage or it's for CO2 enhanced oil recovery. If you're going to leave that CO2 there and get credit for it under the IRS, then you have to do it under a Class 6. But if you just want to do it for enhanced oil recovery, which you can't do in the state any longer, then you could, in other areas of the country, you could just do it for enhanced oil recovery and not take the tax credit.
We do have a great reservoir of wells out there. Of course, they were all, put together for oil and gas production. CO2 injection obviously is much more corrosive, and you also have, the opportunity for the thermal reaction if it flashes from a liquefied injection stream to a gas. So we can't just put regular casing and tubing down there. We can't just repurpose those wells. That's going to take premium pipe, and those lead times are historically very long. In particular, if you're looking at nickel, it's being absorbed by the battery markets and things like that. So that's something to put on to the conversation, about how to get these long lead times down, how to look for more localized production of these type of exotic metallics, not necessarily just chrome 22 and 25, but to consider other things like titanium that can handle the Joule-Thomson effect and be inert to corrosion. Another thing that hasn't been discussed, and it needs to be brought to the fact that one of the reasons these are so expensive is because of the dewatering of the stream before it's injected into the well. That topside equipment is wildly expensive. And to mitigate the corrosion, you either have to do it chemistry or do it with materials, and both of those are very costly and expensive. And if you can't maintain that wellbore integrity for 100 years, your project's failed. So all these great plans of making all these CO2 injection wells, if you don't have a bulletproof, wellbore design, this can all get derailed really quickly with the first Satartius event that has happened over in the east side. So that's something that really needs to be concerned and talked about, and it's not a matter of just repurposing these wells. These wells will be highly designed with exotic materials and handling of the material before they're injected. So just like to put that out there.
Thank you.
That's a good point. I don't disagree with you. It's up to the operator what type of risk that they want to take in terms of repurposing wells. I've got some operators that have said, no, we'd never repurpose an old well. We'd drill a new well. So your point is well taken. I think it's up to the individual business, what risks they're willing to take and what the EPA will be willing to accept as well, because they'll have a say in it.
And some of these wells can be for monitoring rather than injection.
Absolutely, they could be repurposed for monitoring.
Any more questions?
David Allenball, Lawrence Berkeley Lab. There was mention of the risk of CO2 leaking up into the groundwater along old and abandoned wells. But there's also a risk of, the pressure plume possibly driving brine up these wells. And I'm just I'm just wondering which, do the panelists have a concern of one more than the other possibly contaminating the groundwater?
David, I think they're both a concern, certainly to me. Again, it comes down to a strategy of looking at the well penetrations and looking at the formation that you're going to go into. Doing modeling to see what the pressure propagation will be and seeing whether it would drive that fluid into a shallower interval. Now, the EPA takes a very, very conservative approach where they assume that the wellbore is open and filled with brine or with water, which is relatively easy to lift. I think we need to do more research on, actual wells typically are plugged and abandoned with the mud in place. So the mud has a shear strength and will not be lifted like water will be. So there's an opportunity to do some research there, I think, to show that many of these wells may not be an issue. Even if they were plugged and abandoned without casing across the interval. But the first line of defense, I think, is to pick a location where you don't have perforations. You're not going to go into an oil field where you got 1,000 perforations and do it there, but you might find an interval below it that hasn't been penetrated, or maybe it's penetrated with a few exploration wells, and therefore you can pick that location and try to mitigate those 3 or 4 wells. We've seen this in the Rio Vista area.
Any more questions?
Yeah, thank you for the all the panelists, the comments. One question. So, as Rob mentioned, the CO2 sequestration, the storage has been there for a long time, like 20, 30 years. There are a lot of funds, especially in North America or the US, come from the government, like the DOE funds and Q45 tax credit. But another thing is another industry is the financial industry, the banks. And so far, especially in the US, what are the current status for those banks? Because they have their metrics to evaluate projects. Any comment on that?
Do we have the
Sure,
experts?
I'll comment. I think you're seeing BlackRock, one of the world's largest banks, pulling away from some of their climate positions right now because it all comes down to economics. And so it's vitally important to support the legacy oil and gas business if we want the sequestration phase to ever take place. Because we cannot simply force operators out of existence and out of business and then expect tax credits to pay for energy systems that are more expensive than those that we are transitioning away from. So I think, again, it comes down to line of sight for permitting. Money and capital is not going to come into this state if it is not going to generate a return for their shareholders. It simply won't. So I think there's also an opportunity to, again, we're looking at thermal energy storage and the power markets and the cost of power and bringing a solution that can bring down the cost of power and is economic without a tax incentive. So in the sequestration side, legacy oil and gas operators need to be able to make money to do these projects. It's just that simple.
Questions? Over here. This will be the last question.
My question is probably for Matt Herman. Are you advocating a reduction in the CO2, atmospheric CO2 levels, or maintaining what we have today?
I think we need to reduce CO2 in the atmosphere. I think I am not an atmospheric scientist, but my understanding of the literature is that we have not reached equilibrium with current levels of CO2 in the atmosphere, and we have some built-in warming that is yet to happen at these current carbon dioxide levels. So my belief, my feeling is that we need to reduce CO2 in the atmosphere in order to limit future warming.
And have you considered the reduction in agricultural production worldwide when you reduce CO2?
No. Short answer to that is no. I have not thought very hard about agricultural production. No.
That would be a good one to consider.
I think there's a few more panels today. Maybe you can bring that up to them. We're going to end here. Thank you all. Rob Trautz, Matt Herman, Mike Umbro. These kinds of collaborations with diverse audiences is really how we navigate the future in Kern County. So thank you for coming, for joining us, and thanks for having us at CSUB.
Thank you.